I chose was number 18, and the initial condition that we were given was at f of 1, it would equal 3. So therefore, I then I put at y at x equals 1, it would equal 3. And as you can see, as the derivative graph is negative 2, we then know that the slope of this line will be negative 2. We then will look at the area under the x-axis to the derivative graph, and as you can tell, there's 1, 2, 3, 4, 5, 6 squares. So the area is 6. So then we're going to go from this point 3 down 6, and we get negative 3. So because the slope is negative 2, we're going to connect these two with a slope of negative 2 from 3 to negative 3. We then look at the area under this, and we can figure this about 1 and then 2 halves, so about 2. So I'm going to move up 2, and because this is a negative decreasing line, we're going to do a quadratic, as when we're going to have a maxima when this line crosses the x-axis, which has a 0. So then we're going to look at the area under this, and it's negative 0.5. So I'm going to go negative 0.5 under this. So then I have somewhat of a quadratic decreasing concave down graph connected to our straight line. So lastly, we're going to look at this one, and it is a straight line at 1. So therefore, our next graph from to 9 is going to have a positive 1 slope. So as you can see, the area under this graph is 2 squares, so it's going to have an area of 2. So from this point that we did for the negative 0.5, we're going to move up 2, so that's going to go to about 0.5 above the x-axis, and we're going to connect that with a positive 1 slope. So as you can see, our initial condition of the function f is the red graph.